The graph above represents Ser Pounce's adventure to catch a mouse. 10 seconds into his chase, how far is he from his bed? Between 10 and 25 seconds, how fast is Ser Pounce running? Approximately when is he 5 meters away from his bed? And he stops moving when he catches the mouse. When does he catch it? And how far was the mouse from his bed? So let's start at the beginning with part A. 10 seconds into his chase, how far is Ser Pounce from his bed? So we've got time in meters is our explanatory variable on the x-axis, and the distance, time in seconds, and distance in meters is our y-axis, our response variable. So first thing we're going to do is we're just going to label the axes with a proper scale. So we're counting by 5s, 5, 10, 15, 20, 25, and we're going up by 5s as well on the y-axis, the x-axis, up to 60. And we're looking at 10 seconds into the chase, so time is 10. I'm drawing a line up, and then I'll draw a line across to there to figure out the distance after 10 seconds. Ser Pounce is 10 meters away from the bed. Nice and easy. Between 10 and 25 seconds, how fast is Ser Pounce running? So we've got 10 seconds here and we've got 25 seconds, and we're looking for how fast. So let's think about that for a moment and take a minute, think about what that's actually asking us to do here. Well, first let's figure out how far away is Ser Pounce after 10 seconds and how far is he after 25. Maybe that'll help. Because we've just got time and distance here. We don't actually see speed anywhere on this graph. And we're asked for how fast, which is the speed. So after 10 seconds, he's 10 meters away. We knew that already. We did that in part A. And after 25 seconds, do a similar process and say, okay, well, he is 15 seconds away, or 15 meters away. Now, how fast? That's the speed. Speed is usually meters per second or kilometers per hour. Well, that's distance over time. That's the gradient. So we're being asked for the gradient of this line segment here. So the gradient, rise over run, sub in my 2 points, 5 over 15, which is 1 over 3. So we can make our final conclusion. Ser Pounce is moving at 1/3 of a meter per second, or 0. This just means 3 repeated, so 3, 3, 3, etc. meters per second, between 10 and 25 seconds. Just going to make a note here. Do not forget your units. So when we're dealing with speed, I want to see meters per second. Part C. Approximately when is Ser Pounce 5 meters away from his bed? Well, distance is 5 meters. So we're going to use interpolation here to figure out what x values, with times, or time, he is 5 meters away. So I'm just going to draw a line through here, and I can see that he is 5 meters away from the bed, about here, and about there. Draw those 2 lines down. So at approximately 7.5 seconds, if you said 8 or 7, that's okay, and 55 seconds. So there are 2 times where he's that far away from the bed. Lastly, part D, he stops moving when he catches the mouse. So when does he catch it, and how far away was the mouse from the bed? So, again, this one's a little bit trickier. Pause and think for a moment about what that means. If he's stopped moving, what can you tell me about that? Well, if he's stopped moving, that means that his speed, which is the gradient, is 0. A speed of 0 means there's no gradient, there's no change, he's not moving, the distance isn't changing. So we're looking for a horizontal line, a horizontal part of the graph, which is just there. So that's the section of the graph here that we care about. So when does he catch the mouse? He stops moving when he catches it. So just drawing that line up there. He catches the mouse after about 25 seconds. And how far was the mouse from his bed? Well, where is he when he stops? Draw our line across to distance. He's about 15 meters away from the bed. And that is example 1.